Good morning. Happy Monday. Hope you guys had a great weekend. We are on number 12. So first we have to code classify, which just means kind of like identify or name. Name the polygon. Remember, polygon is a 3 or more sided shape with straight lines that is closed and it's flat. The polygon at the beginning of each row as a rhombus, a rectangle, or both a rhombus and a rectangle, or neither a rhombus nor a rectangle. Alright, so that means we can fill in both of them, fill in none of them, or fill in one of them. So this is going to be definitely a rectangle because it has right angles. Remember, to find a right angle, you would get a piece of paper and just fit it in the corner. And yep, that is a right angle. And then you can match all of them. And a rectangle has 4 right angles. So that is definitely a rectangle. This one is not a rectangle because it doesn't have the right angles. This one is a rectangle definitely because it has those right angles, 4 sides. This one does not have right angles. Let me show you. So this is the right angle paper. Any paper really has right angles, and see when you put that there, see it doesn't perfectly fit. So that one's not. Alright, a rhombus is going to have all the same sides. So this one, this same length, same side lengths. It's kind of like a square, but it doesn't have to have right angles. So this is a rectangle, and it's a rhombus because it has the same sides. This side equals this side, which is this side, and this is a square. Now this one, this side and this side are the same. They're all the same, but it doesn't have right angles, so it's only a rhombus. And a rectangle can have different side lengths, but it has 4 right angles. Okay, so I'm going to mark these as right. Remember that the little symbol for right is just like a little square corner. So this one has 4 square corners. That's a rectangle. 4 right angles. That's a rectangle. This one does not, so it has like a circle. That's just a regular angle symbol. But it does have the same side lengths. All the sides are the same side, that's why it's a rhombus. And this one's actually a trapezoid. Now it does not have see how this side is longer than this side? So, alright, what is 389 rounded to the nearest 100? So I'm looking at this place value right here. That's going to be my first 100 on the number line. 300, and the next 100 will be 400. Right in the middle will be 350. And then where would 389 go on here? Would it go on the A side or the B side? Well, 389 would go over here on the B side, which means it would be closer to 400. So that's my answer, 400. So make sure you bubble right underneath. Notice where I put the 4 all the way to the left, and I have to put those 2 zeros in, 400. Okay, number 3. What fraction represents the point on the number line? First of all, I notice that this is where my hole is, and it starts with 0. That means all this are equally cut a hole. So we need to see how many pieces. So 1, 2. Notice how I'm counting the spaces and not the lines, but the spaces. 3, 4, 5, 6, 7, 8. So they split this hole up into 8 pieces. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8 pieces. Alright, I'm going to erase that. And I'm going to number this number line. So this is 0 eighths. This would be 1 8, 2 8. And since 4 eighths is right in the middle, there's going to be 4 on this side and 4 on this side. This is also equivalent to 1/2. 4 eighths and 1/2 are the same thing. 6 eighths, 7 eighths, and 1 whole is going to be equivalent to 8 shaded parts out of 8 parts. Now this is at, the dot is going to be at 1/8. So which fraction represents the point on the number line below? So remember, a fraction has to have a numerator. This numerator is how many shaded pieces, so I could shade this first piece. 1 is in the numerator, so this could be it. Maybe, no, and no. So now it's down to A and B. 8 will be in the denominator because that's how many pieces are in this hole. And so it's not A, it has to be B. Okay, last one. Sam's dad built him a sandbox. The area of the sandbox, area is rows times columns, of the sandbox is 25 square units. They already give us the area. Select the sandbox that could be Sam's. Well, I'm going to count the rows. 1, 2, 3, 4. 4, and this one would be 1, 2, 3, 4, 5. I know 4 times 5 is 20, so that's going to be 20 square units. This one is 1, 2, 3. 1, 2, 3, 4, 5, 6. 3 times 6 is 18 square units. This one, 1, 2, 3, 4, 5 rows. And 1, 2, 3, 4, 5. I know 5 times 5 is 25. This one I can't use my rows times columns because it's not an exact rectangle. So let's just count because it has the squares for us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. By the way, you could use this strategy with any of these. I like to use the rows times columns because it's faster. But since it already has the boxes for you, the little squares, you could use this strategy. And it's a good way to double check it as well. But sometimes they don't have the lines in there and you have to use rows times columns. 13, 14, 15, 16, 17, 18, 19, and 20. So this one's going to be 20 square units. Alright, so let's go back to our question. The area of the sandbox is 25. That is C over here. Select the sandbox that could be Sam. So this sandbox is the only one with 25 square units, so I'm going to bubble that in. And that is it. Alright, I'll see you guys tomorrow.